Now, in this video, we will going to take up the second case where the shortest link is the fixed link. So here, continuing from the same video, that model what we have created for the first one, that is for the crank or mechanism. Now, I want to fix the shortest link, which is the shortest link. That is, S is the shortest link, which I want to fix it. Suppose if I want to fix the shortest link, now at present, Q is the link which has been grounded. So I want to remove that grounded link, which is link Q. So I'll just take the cursor onto that link and right click on that and remove unground from parent. Once you remove from unground from parent, now the link is open. Now I want the link S to be fixed. Since the link is to be fixed, so I will just go to the link S and right click and create ground to parent. Once you do that, now your existing assembly relationship, now ground to parent may cause assembly conflicts and the components may revert to their initial insert or in place creation positions. The following selected components have an existing relationship, that is link S1. I want to make that link S1 to be grounded to parent. Once you do that, now the link S will be horizontal. This is grounded to parent. Now I want to give the motion. So for to give that, I will just go to joints, right click on that, animate joint relationship. So you just click on this. Now you can see which is a double crank mechanism, wherein you can see double crank mechanism where the two cranks, that is this blue and this red, will going to be start rotating. So that means you can see this is one, that is red and blue, both will be rotating by an angle of 360 degrees on either side. Since both are being rotating, that is why it is called double crank mechanism. So this is how you will be able to get the second inversion of Grashof mechanism, wherein these two links will be rotating by an angle of revoluting by the angle of 360 degrees. So this is what is called double crank mechanism. So now I will going to by pressing the escape key, we are going to stop this. Now I will go to file, then click on save as, then go to here in the Grashof law. Here you make double crank mechanism. So this is double crank mechanism. This is the second case, double crank mechanism. So I'm going to save this as the double crank mechanism. So wherein the shortest link is fixed, whereas this P and this Q and L will be rotating continuously by an angle of 360 degrees. Now, the next condition, what he says, this is shortest link is opposite to the fixed link. So since I want the shortest link should be opposite to the fixed link. So now, which is the shortest link? Shortest link is this. Opposite that is this one. So to do that, so first I want the link P to be fixed. So since I want the link P to be fixed, I will just go to right click on this, remove unground from parent. Now I'll go for link P. That is the one which I want to fix it. I will just go to right click on link P and so go to parent and say click on ground to parent. Now this is the one that link P is fixed. Shortest link is opposite to the fixed link. So now this is the fixed link. The shortest link is opposite to this fixed link. Now I will just go to relationship, right click and take the animate joint. Now you can see that this crank, which will be rotating here, it is oscillating by about the two ends of the fixed link, and whereas the shortest link will be rotating by an angle of 360 degrees. This link, which is called as the double rocker mechanism. So we have this as the double rocker mechanism. So here, these two rockers will be oscillating, whereas the smallest link will be rotating by an angle of 360 degrees. So this is known as the double rocker mechanism. I will going to get press escape. Now I will go for file, click on save as, then come down to double rocker mechanism. This is the third class, class 3 of or the inversion of third condition, double rocker mechanism of Grashof law. Click on save. So this is how you will be able to explain the simulation or the animation of the Grashof mechanism of class 1, 2, and 3. Thank you.